Morning, everyone. Welcome to our second forecast webinar for 2016. This is Dan Sandig with the Institute for Catastrophic Loss Reduction. I'll be moderating the questions today after the presentation. So we're very happy to have Bob Robichaud from the Canadian Hurricane Center talking to us today. Before we get started, a couple of reminders. First, our next webinar will be on June 17th. And we'll have Dr. Eric Robinson from AIR's Research and Modeling Department in to talk about catastrophe scenarios for winter storms, severe thunderstorm, and tropical cyclones for Canada. And that also will be an all-webinar event on June 17th. For the webinar today, we'll be taking questions only by the Q&A box through the webinar software. So feel free to submit your questions throughout the webinar, and we'll be holding questions till the end. But as you have questions, please submit them, and we'll collect them and make sure they get asked. So with that, we have Bob Robichaud, who is a warning and preparedness meteorologist at the Canadian Hurricane Center. Bob's has been with Environment Canada since 1998 and has been in his position since 2004. Bob works closely with emergency management officials on training, support, and during actual hurricane events. And he works out of Atlantic Canada's Canadian Hurricane Center. This is another event in the series of presentations that we've had with Bob over the past few years. And they're always very interesting, and we always look forward to them. So with that, I'll pass it over to Bob Robichaud.
Okay, thanks, Dan. I'll just share my screen here. Okay. So what I'm going to be covering today is kind of starting off, as I usually do, with a kind of a basic overview of tropical cyclones, what they are, and I'll do that by covering what I call the 5 W's of tropical cyclones. Then I'll talk a little bit about the hazards associated with these tropical cyclones. And then we'll do a quick review of what occurred last year, even though there were fewer storms than average last year. There was quite a bit of damage, especially as a result of a couple of these storms. We'll look ahead at 2016, and I'll finish up with a couple of websites you can look at and tools to use when these storms are approaching. So one of the questions that I often get is, who is responsible for issuing tropical forecasts for tropical cyclones? We have our Hurricane Center here in Canada. There's the National Hurricane Center in the United States. Well, it turns out under international agreement, the different ocean basins that do get these storms, we've divided it up into 7 different basins and seven different what we call regional specific meteorological centers. And for the Atlantic and the Eastern Pacific, it's Miami's National Hurricane Center that issues the forecast and advisories for those 2 ocean basins. And within that group, we are part of, along with the U.S. and some Caribbean, all the Caribbean countries, Central America, Mexico, and Bermuda, we make up what is called the Regional Association 4, which is essentially a group that sits down and discusses how these forecasts are issued, any names of the storms that need to be retired, that sort of thing. So there's a fairly close-knit international group that oversees how these tropical cyclones are handled from a forecasting perspective. We here at the Canadian Hurricane Center, we're not in competition at all with the Hurricane Center in Miami. In fact, it's the opposite. We work closely together. We send a few forecasters down there every year for specific training on how to forecast these things. What we do is we provide specific information as it affects Canada. So what we would do on when the storm is approaching, about 72 hours before we expect a storm to cross this thin line here, the response zone, not our area of responsibility for issuing forecasts, but this response zone, we would start issuing track forecasts and bulletins on those specific storms. So we're here to add specific information as it relates to Canada. So what are these tropical cyclones? Well, tropical cyclones are relatively large and long-lasting areas of low pressure that form over warm water. And to be classified as a tropical cyclone, we must have an area of closed circulation that's well defined around that center. And some of you may have seen Bonnie over the weekend, developed late last week, and that's what we were actually waiting for it to actually be declared a tropical cyclone, was to find that center of circulation. It wasn't until an aircraft was sent in there that they were able to identify that center, and then it became classified as a tropical storm and got the name Bonnie late on Friday. These storms are classified by maximum sustained surface winds, so it's not by rainfall, not by storm surge or low pressure. They're classified by maximum sustained surface winds. And when a storm does not have a closed center of circulation and the winds are less than 37 kilometers per hour, it gets classified as a tropical disturbance, and they're monitored for any further development. When we can identify a closed center of circulation, in this case, it's not where this clump of cloud is, it's actually right in here, is where the center of circulation is, and the winds reach at least 37 kilometers an hour. That's when it gets a number and it gets classified as a tropical depression. If that storm is allowed to further intensify and the winds reach at least 63 kilometers an hour, that's when it gets the name, and it gets classified as a tropical storm. And then the different classes of hurricanes start at 118 kilometers an hour, and then anything above 178 is classified as a major hurricane. And you can see how these satellite images show progressively a more organized and symmetric storm, the more intense the storm becomes. In terms of the structure of these storms, we have the center of circulation, and we have these bands of progressively heavier precipitation and stronger winds as you move towards the center of the storm. All these are bands of a thunderstorm activity within the storm itself. So if this is a cross section, there's a tremendous amount of air that rises within a hurricane. Most of it flows up the top. Some of it actually flows in towards the center. And whenever we have descending air, we tend to see a phenomenon that dries the air out, and that's why the eye of a hurricane, at least a more developed hurricane, is actually clear, often clear right down to the ocean surface. And that's why we have the eye within a hurricane, and then the strongest winds and the heaviest rain is within that first band, or it's actually a ring around the center, and we call that the eye wall. So if we look at the distribution of winds in a tropical cyclone, a well-developed hurricane, your strongest winds are right near the center. The center is actually quite calm, but the first band around the center of the storm is called the eye wall, and as I mentioned, that's where you're going to find your strongest winds, and then you get a little bit of a drop off until you get into the next band, and then so on and so forth until you get out of the storm altogether. And the circulation in the northern hemisphere in tropical cyclones is counterclockwise. Now, a particular phenomenon that occurs when a storm approaches Canada is the storm actually gets bigger. The size of the storm increases. Now, the actual winds may not be quite as strong as in a very strong hurricane, but they can certainly be very damaging. Now, the maximum winds actually moves away from the center, and it can be found quite some distance, hundreds of kilometers away from the center, and are found on the right-hand side of the track, whereas the rain typically shifts to the left-hand side of the track. So that's something that we know happens. First of all, the storm accelerates, it gets bigger, the rain goes to the left and the strongest winds go to the right. Now, when do these storms form? Well, hurricane season starts June 1st, in a couple of days from now, and extends to the end of November. However, there have been storms in every month of the year, and this year's a good example. We had our first hurricane develop in January, which was the first time that's happened since 1938. So pretty rare event this past January with Hurricane Alex that developed. And of course we had Bonnie just over the weekend, so we've had two named storms now outside the official start of hurricane season. Things really start to get going around mid-August, and the peak of hurricane season being the month of September, and then it kind of drops off towards the end of October into November. Where do these storms form? Well, it turns out that there are specific locations within the Atlantic that these storms will develop that favor development. Early in the season, we typically see storms developing either in the Gulf of Mexico or off the east coast of the United States. Once we get into the more active part of hurricane season, your most likely area of formation kind of migrates east a little bit. And then you can see here in September, it can be pretty much anywhere from off the coast of Africa into, as you approach the Caribbean and in the Gulf of Mexico. And once we get into October, it starts to migrate westward again. And then finally in November, things start to die down somewhat. So why do they form? There is actually a purpose that hurricanes do serve. The whole purpose of a hurricane is to counteract an imbalance in the ocean temperature. Over the course of the summertime, when we start to tilt towards the sun in the northern hemisphere, the sun heats up the ocean and the ocean becomes quite warm. And the purpose of the hurricane is to take some of that heat and pump it into the atmosphere, and that regulates the planet's temperature. If we didn't have that, you probably wouldn't see the number of hurricanes that we have in the various ocean basins. So now I'll shift gears a little bit and talk about the hazards that these storms bring. Of course, they bring strong winds, and that's what really defines their intensity is the wind speed. They also bring waves and storm surge, and oftentimes the most destructive part of that is a combination of both. And of course they do bring heavy rains and flash flooding conditions. In some of the more purely tropical type storms, they can also spawn tornadoes, but that's not really a significant hazard that we see here in Canada. For us, it's typically the winds and the water that cause the problems with these types of storms. So I mentioned when a storm becomes post-tropical that there's quite a large difference in wind speed from one side to the other. That's because we always have to take into account, when we're talking about wind speed, is the circulation speed and the speed of forward motion of the storm. Now, when we have a pure hurricane, the circulation speed is much, much higher than the forward motion because these storms tend to move slowly when they're in the tropics. So even though there is a slight difference from the right-hand side to the left-hand side, that difference is pretty minimal given the slow speed of motion and given the strong speed of the wind circulating around the center. Now, when a storm approaches us, I mentioned earlier, it gets bigger. It also increases in forward speed, so the storm actually speeds up. And when it speeds up, what you have to do, obviously, is to subtract the speed of forward motion on the left-hand side and add it to the right-hand side. So that difference between the right and the left gets quite significant when a storm is becoming post-tropical. That's why we always say the strongest winds are almost always going to be on the right-hand side. That doesn't mean that they can't be damaging on the left-hand side. Sometimes they can interact with an existing weather system as the storm comes up, and that can produce strong winds on the left-hand side. But whenever you do have damaging winds on the left-hand side, they'll invariably be stronger on the right-hand side. And this is a representation of that. We did a study a few years back looking at a number of cases of storms that have entered our response zone. And in 81% of the cases, the strongest winds that were actually measured were on the right-hand side of the storm. And actually half of those, just over half, were actually in the southwestern or the right rear quadrant of where the storm, if you think the center of the storm is in here, the right rear quadrant is where most of the stronger wind gusts were actually recorded. And in a few cases, the strongest winds that were actually measured were on the left-hand side, but in most of these cases, we suspect that there were even stronger winds on the right-hand side. It's just that it didn't happen to go over any ship or buoy or land station to actually capture that wind speed. Also, I mentioned rainfall. Rainfall is just a fact of life with these types of storms. By their nature, you can get very high rainfall rates, extreme rainfall rates of 20, I've seen even 50 plus millimeters per hour. And when they become post-tropical, as I mentioned, most of the time the heaviest rain shifts to the left-hand side of the track. Every now and then we'll see a storm that actually taps into a tropical system that's quite a distance away and actually entrain some of the moisture and pick up some of that moisture and feeds into another system. And we call these atmospheric rivers, and they can extend thousands of kilometers, and we've seen a number of cases over the years where that's happened and resulted in flooding events. And this was an example of this type of phenomenon where it tapped into the weather system tapped into the moisture from Hurricane Tomas 2010 and caused some record flooding in southern New Brunswick and the western part of Nova Scotia. These rivers can, atmospheric rivers can occur any time of year, and they don't always have to tap into an actual tropical cyclone. They just have to tap into some tropical moisture, and when this weather setup occurs, we tend to see some very heavy rainfall and almost always some degree of flooding. We also have storm surge. Storm surge is really just an abnormal rise in water level at the coastline that's generated by the storm. Essentially, the wind blows the water on shore. And there are a number of factors that affect the storm surge: height, the speed of the wind, obviously, and the direction of motion. If you have more of a direct hit as opposed to a glancing blow, you'll see some higher storm surge there. The size of the storm, hurricane or a post-tropical storm Sandy in 2012. A lot of the storm surge that we saw along the Atlantic coast in New York, New Jersey, was a result of the sheer size of the storm when it made landfall in that area. And also the coastal bathymetry also plays a role. We tend to see higher storm surge events along the Gulf Coast of the United States as opposed to, say, Newfoundland, that has a very different shape to its coastline under the water. Now, another thing that's unique to tropical cyclones that move up into Canadian waters is we tend to get very, very large waves occurring as a result of these storms. If you think of the case of a hurricane, I mentioned how slow hurricanes actually move. Hurricanes, if you think of the large yellow arrow as the storm, or the area within the storm that's actually generating waves, the storm actually moves quite slowly. In the case of a slow-moving hurricane or tropical storm, the waves move out ahead of the storm, and the storm lags behind. In the case of a winter storms tend to move quite a bit faster than tropical cyclones do when they're in the tropics. And what we often see is the storm actually outstrips its own waves. So the storm will go by, you'll get your strong winds, your precipitation, and then some of the larger swell associated with the storm that just went by then has an impact on some coastal infrastructure. But if you think of a case where you have a slow-moving storm, which is generating waves, pumping the waves out ahead of it, but then it starts to accelerate like post-tropical storms will do, you tend to have a certain period of time where the area that's generating the waves and the actual waves are actually in harmony. And in those cases, the longer that occurs, the larger these waves are going to get, and you can end up with some extraordinarily large waves. And if you get this in combination with a storm surge, it has the potential for significant damage all along the coastline. And we've also seen this occur out in the open sea, where ships have been caught in this, and some have been able to get out of it, and some not. So this only happens because the storm is actually increasing in forward motion. So we get larger waves with these post-tropical storms than we do with actual hurricanes. So now we'll shift gears a little bit and look at the 2015 season in review. Like I said, it was even though we only had 11 named storms, it was an active season on a couple of different levels. This image up here is as good an image you'll see of a nice symmetric hurricane, and this was actually a storm that occurred in the Pacific, not a basin that we typically have to pay attention to here at the Canadian Hurricane Center, because in Canada most of our tropical type storms come from the Atlantic, so we have a larger focus on the Atlantic. But this was a Pacific storm, Patricia, at the end of October, which ended up being the strongest tropical cyclone on record, with maximum winds of 343 kilometers an hour. This photo here on the right-hand side is Joaquin, that actually formed in late September and caused the sinking of the cargo ship El Faro and some other damage, significant damage in the Bahamas. So if we look at what we talked about last year during the same briefing, the agency in the U.S., the National Oceanographic and Atmospheric Administration, who issues these forecasts, and incidentally, it's the Climate Prediction Center that actually issues these forecasts, not the Hurricane Center in Miami. But their forecast last year was for 6 to 11 named storms, and we got 11. 3 to 6 of those becoming hurricanes, and we got 4, and then up to 2 of those hurricanes making it to major hurricane status, and we did have 2 major hurricanes in the Atlantic last year. So this is a representation of the storm tracks from last year. We had kind of 2 clusters, storms that formed in the just off the coast of Africa in the eastern part of the Atlantic, and then the ones that occurred in the Caribbean or off the southeast coast of the U.S. Only one actually developed in the Gulf of Mexico last year. As far as we're concerned here in Canada, we had 4 storms that entered our response zone, and that's kind of in line with what the average is for a typical year. We typically have about 4 that enters our response zone. Luckily, we didn't have a whole lot of impact from any of these storms. The first one was Anna, that occurred again in May. It was a preseason storm. It just barely entered our response zone and didn't create much havoc at all here for Canada. And then in July, we had a storm that formed just off the coast of the Carolinas and became a tropical storm before weakening somewhat and becoming post-tropical. Now, this storm did produce some heavy showers in Newfoundland and Labrador, but they were fairly isolated and didn't present much of a problem anywhere in Canada. We had Henri, also developed over the open water, and was a very short-lived storm. And again, no impacts at all in Canada for Henri. And then by far the storm of the year in the Atlantic Ocean was Joaquin. Joaquin became a tropical storm on September 28th, and 2 days later it went from a Category 1 to a Category 3 in only 12 hours. And this is still one of the challenges that we have in forecasting these things. It's forecasting this rapid intensification. We know that there's still a lot we need to learn about how storms intensify, especially when they intensify this rapidly. And this storm here intensified, not only intensified rapidly, but was headed in a kind of abnormal southwesterly direction, and then impacted the Bahamas as a Category 4, which was the first Category 4 hurricane to impact the Bahamas since the 1800s. It also resulted in the sinking of the El Faro that I mentioned earlier, El Faro that left Jacksonville on its way to Puerto Rico and just happened to be at the wrong place at the wrong time while the storm was rapidly intensifying. There was some indications that the storm could follow a similar track as Sandy did and come up either into the mid-Atlantic states, and then maybe a day or so later the models kind of suggested it might make landfall somewhere in the northeast or somewhere in eastern Canada. But in the end the storm stayed offshore and really didn't have a major impact in Canada at all. There was some swell that reached the Atlantic coast of Nova Scotia and Newfoundland and Labrador, but otherwise no impacts here with that storm. Now, once we had a pretty good handle on the storm, that we knew it wasn't going to make impact, it wasn't going to make landfall anywhere in North America, still, as the storm was actually heading out to sea, this other system that developed just off the coast of the southeastern part of the U.S., which was incidentally related to another trough of low pressure that resulted in heavy rain over New Brunswick. They had over 200 millimeters of rain on October 1st, and that caused some road washouts and flooding. But associated with that storm that affected New Brunswick was this trough that was just off the coast of the U.S. and developed into a stationary weather system that actually entrained some of the moisture associated with Joaquin as Joaquin was going by, and that resulted in very significant heavy rainfall in South Carolina, and that was later categorized at about a 1 in 1,000 year event rainfall. And this is a representation of the rainfall that occurred in South Carolina. The maximum amounts that I found were 722 millimeters that occurred near Charleston, and that's an equivalent of about 11 trillion gallons of water that fell on Charleston in that 3-day period, obviously resulting in record flooding for that state, a state that's about the size of New Brunswick. Their state EOC, Emergency Operations Center, was activated on October 1st and remained active 24/7 up until October 23rd. And here are some of the impacts that we saw with that particular rainfall event. Again, not directly tied to a specific tropical cyclone, but indirectly affected by the passing of Joaquin just to the east. And there's just some amazing pictures that came from South Carolina in the days following this flood. They had over 500 road and bridge closures as a result of the storm. So something that they're actually still recovering from right now. So now we'll take a look ahead at what we might expect for this hurricane season. And as I mentioned earlier, NOAA, who issues these forecasts on an annual basis, came out with their forecast last Friday afternoon. And what they're calling for is anywhere from 10 to 16 named storms. So they're expecting certainly a more active year than we had last year. with 4 to 8 of those named storms making it to hurricane status, and between 1 and 4 of those 4 to 8 hurricanes actually reaching major hurricane status. And you can see how that compares to what is average for a particular year in the Atlantic Ocean. So by their definition, these numbers 10 to 16 and 4 to 8 and 1 to 4 are right in that average category. So they're thinking it's going to be near average or slightly above average. That's kind of where things are leaning with respect to the forecast for this year. Now, there's a number of things that we look at to determine what is going to influence hurricane season. One of the things that we've seen over the last, certainly last year and somewhat towards the end of the previous hurricane season, was the El Nino. The El Nino is essentially a condition where we have unusually warm water off the coast of South America, near the equator, basically in this black box here that I've outlined, and this is the water temperature that we saw back in December of 2015, so essentially at the end of last hurricane season. And I got this same image from this morning, and you can see how this red has actually changed to blue. So the red indicating, you know, much warmer than average water, and then the image from this morning indicating that things are on their way to being cooler than average. And we expect this trend to continue right through hurricane season. So when we tend to have this kind of scenario, this El Nino condition causes wind shear downstream over the tropical Atlantic. So whenever we have an El Nino, we tend to have fewer storms. And right now we're actually headed to the opposite of El Nino, which is called La Nina, and that would indicate lower wind shear and more favorable conditions for hurricane formation. So this is kind of different model representations of the water temperature within that black box. And you can see that the trend is downward. Anything warmer than half a degree Celsius above average is considered El Nino, and then we have the weak, moderate, and strong El Nino, which is what we were in last year. Anything between 0.5 degrees colder and 0.5 degrees warmer is considered neutral, and anything colder than 0.5 degrees colder than average is considered La Nina. So you can see that most of these models, by the peak of hurricane season, which I've outlined here between these two yellow lines, most of these models have either a neutral or a La Nina condition by the time we get into the peak of hurricane season. So that inhibitor that was there last year is no longer there this year, and that's one of the main reasons why we think there's going to be more activity this year than there was last year. As far as the hurricane names go, I mentioned that we had one already in January with Alex, and then Bonnie that formed, didn't make it hurricane status, but made it to tropical storm status over the weekend. The next named storm that we see in the Atlantic will be Colin, and then we'll just go down the list from there. The list that was used last year will be used again in 2021, with the exception of 2 storms which were retired from the list of names. Erica has been replaced by Elsa because of severe flooding in Dominica, and also Joaquin was replaced by Julian for the damage that it did in the Bahamas. So these 2 countries made an application to this RA4 group that Canada sits on, and made the application to get those respective names removed from the list, and it was approved at a meeting back in April, and these are the names that actually replaced those 2 storms from last year. So I'll just finish off with some tools that you can look at as we head into the official start of hurricane season. The best thing to look at if you get in a routine of looking at things in the morning is looking at the tropical weather outlook, and I'll kind of show you examples of what these things are. But the tropical weather outlook is essentially a tool that gives you an indication of possible tropical cyclone formation within a 2 and a 5-day period. Any storm that has the potential to form within either a 2 or 5-day period. So there are 2 maps that you can look at, one for 2 days, one for 5 days. Now, and that was something that you could probably look at a couple of times a day just to see if there are anything that pops up there. This is usually where you'll get your first indication that a storm is brewing out in the Atlantic. Once a storm actually develops, you can look at the detailed information from that storm on the National Hurricane Center website, their track and intensity forecast. The other thing that's also very good to look at, especially with respect to wind and potential wind damage, is the National Hurricane Center wind probability map. And we'll look at that as well. This you can look at throughout any lifetime of the storm, even if a storm is approaching Canada. So if a storm is not necessarily approaching Canada, we'll have our track on our website, but we won't necessarily have any detailed text information to go with that. So you have to still look at the National Hurricane Center information for that. Now, once we get into that 3 to 4 day period before a storm is actually going to make some kind of an appearance in Canada, the Canadian Hurricane Center will initiate the issuance of bulletins and our own track forecast on that particular storm, and that's where you kind of transition from the NHC to the CHC products, is in that 3 to 4 day time frame. And once the storm is about 36 hours away is when we start to issue the watches, and then 24 hours before is when we start issuing the warnings. And then you also look at not just the Canadian Hurricane Center warnings, but the warnings from your regional Storm Prediction Center. So if we're talking Ontario, it would be the Ontario Storm Prediction Center who would be issuing, say, the wind and rainfall warnings. But if we expect, say, tropical storm warnings to be issued, they would be issued by the Hurricane Center. So you might have a suite of 3 or 4 different warning types in your particular forecast. So that gives you a timeline of things to look at as a storm is approaching. So this is the tropical weather outlook. It gives you essentially the probability of formation based on different categories, low, medium, or high. And again, excuse me, this is the link to actually get to this website to look at this kind of stuff. And then once the storm is actually formed, again, well before it has a potential impact in Canada, you'll want to kind of focus on what they're saying at the National Hurricane Center. Again, the website for that, nhc.noaa.gov, and you'll get the forecast track. You'll get any kind of text bulletin that goes with that, along with these wind probability maps. And this is what I was talking about earlier. And you have wind probability threshold maps for 3 different thresholds of winds. One is for tropical storm force winds, so around 70 kilometers an hour. And then you have another one which is for 50-knot winds, or around 95 kilometers an hour. And then you have one for hurricane force winds. So you can see the probability of those types of winds. And what you also want to do is kind of, and these are updated every 6 hours, so you want to kind of look at what the trend is. Is the trend going up? Is it going down? Even a low probability of a very high impact event often is something that requires some sort of action. Now, when the storm is approaching Canada and is expected to have some sort of an impact, this is where you'll find the Canadian Hurricane Center bulletins and the forecast track is at hurricanes.ca. And again, that would be about 3 to 4 days out is when we'd have details on a storm that would impact us. So once I talked about the watches and warnings, once we get into that time frame of 36 hours or less, 36 hours is when we would start issuing the watches, which means that conditions are favorable for that hazard to occur. And that gives us a little bit of leeway here to keep watching things. Once we have a lot better confidence that it's actually going to happen, then we would actually issue a warning. And that's typically about 24 hours ahead of time. And it means that the conditions, whether it's a tropical storm or a hurricane warning, that the conditions are either occurring now or about to occur within that 24-hour time frame. One of the things we've been trying to get more active on is over the years is social media. We haven't had a whole lot of storms here in the last year or two to test a lot of the things we want to test out. We have our seasonal briefings that we do with the media once these seasonal forecasts are released on YouTube. We actually also have the individual storm briefings on YouTube as well. One of the things we're planning for this year is a tweet chat. Probably look for that sometime in September, preferably when a storm is not at our doorstep. I don't think you'll see that when a storm is approaching, but I think sometime in September, when we can find a window, we'll actually have a tweet chat, which is essentially a session about an hour long where people can come in and ask questions. Another thing that we're looking at introducing this year in our hurricane bulletins is something right at the top of the bulletin called our key messages, and basically summarizes the bulletin with the key messages that we want the media to pick up on. And since they're included in the bulletin, they will be fully translated, and then this is something that we can either do and modify it to put in a tweet, or come up with a slide that that we can put on to tweet that out as well, or put that on our Facebook page. So just to summarize, the number of tropical storms and hurricanes this year is expected to be near or slightly above normal for a typical year in the Atlantic Ocean. One of the key weather patterns that reduces hurricane activity in the Atlantic, the El Nino, is not expected to be a factor this year. There's about a 70% chance that we'll actually be in a La Nina by the peak of hurricane season. So it's not a 0% chance that it won't be a factor, but more than likely it won't. There's some theories out there just based on some other cycles that are going on in the Atlantic Ocean that would suggest that more of our hurricanes and tropical storms will develop in the eastern part of the Atlantic, the western part of the Atlantic, or the Gulf of Mexico this year, as opposed to the storms developing off the coast of Africa. And if we do get a near normal season this year with somewhere around 12 named storms, it would be the 4th year in a row that we have either average or below average number of named storms out there, which has never really happened in a period of heightened hurricane activity. So if we do get around 12 storms this year, it may be an indication that we're going into a period of fewer hurricanes, and that's a typical cycle that we see in the Atlantic Ocean that kind of happens every 20 to 30 years. So we've been in an active phase since 1995, and the last couple of years have been below average, but that has been largely because of El Nino. So with El Nino gone, we're going to get a good indication this year, I think, of whether we're heading back into a period of lower activity, or if now we are back into the higher numbers that we've seen prior to 2013. So that is the forecast for this year. Again, our message remains the same. It doesn't matter how many storms are actually predicted in the Atlantic Ocean, it only takes that one storm to make it a bad year if that storm actually impacts you or your family. So we tell people to just get prepared for the season, regardless of whether we're calling for an active one or an inactive one. So with that, Dan, I'll hand it back to you to see if there are any questions.
Great, thanks very much. So it was an excellent presentation. So there were a couple of questions online, or a number of questions online. Actually, one that came up a few times was whether or not the presentation will be available afterward. And we are recording it, and we'll post it on our YouTube site. So we'll send some information on that when it's ready to go. It should be ready later this week. So one question that we had online sort of related to what you were just stating, are the strongest hurricanes those that form off the coast of Africa versus those that start in the Caribbean, or is there any sort of significant difference?
Yeah, there actually is. Most, and this is kind of a general rule, it's not necessarily every case, but what we tend to see is when the disturbances come off the coast of Africa, and then they start to acquire tropical characteristics, and then eventually you get that closed center of circulation, and then from there you get the intensification. Just because the storm has so much time over that warm water as it's moving westward across the tropical Atlantic, they tend to reach higher intensity than a storm that forms, say, in the Gulf of Mexico or in the Caribbean, because a storm forming in the Caribbean, especially a storm that's just forming east of the Caribbean, will almost always have to kind of make its way over land. And whenever you have a storm moving over land, it loses some of its intensity. So when they're just forming just east of land, they don't have that time to actually develop into a very strong storm. Now some do, of course. So you can still easily get a major hurricane develop just over the just east of the islands, or in the Gulf of Mexico for that matter, or one developing off the southeast coast of the U.S. But as a rule, the ones developing off the coast of Africa tend to, everything else being equal, tend to reach stronger intensity because it has more time to intensify.
Okay, great, makes sense. Another question related to NOAA's statements last week on the upcoming hurricane season. They were saying that the 2016 Atlantic hurricane season was going to be particularly hard to predict. Do you have any sense of why that was? Yeah,
the one thing that I really didn't get into a whole lot of detail was another large-scale pattern. I talked about El Nino, but the other large-scale pattern that I'll try and simplify as much as I can is something called the MAO, or Atlantic Multi-Decadal Oscillation. And that's essentially a cycle that occurs in the Atlantic Ocean. And that's the cycle that tends to be on that average of 20 to 30 years. So when we see the MAO in a certain phase, it tends to result in fewer hurricanes. And it's a really tricky one to observe, because we can get a pretty good idea of whether or not we're in an El Nino or La Nina situation just by looking at the water temperatures in that part of the Pacific. It's a lot harder to observe the cycles involved in the MAO. In fact, we've never seen a shift from one phase to the other phase. It's pretty much theoretical at this point. But the idea is that we get this period of warmer water in the Atlantic Ocean that results in heightened tropical cyclone activity on the average of 20 to 30 years, and then it shifts back to a kind of a colder regime, and then we tend to get a period of 20, 30 years of fewer hurricanes. And we saw that the 1930s were busy, not so much in the 40s. In the late 50s, early 60s, it was busy again, and then it dropped off in the 70s and 80s, and then in 95, boom, the switch turned back on again, and we've been in that heightened period since 1995. The big question is, are we heading back into a period that has less hurricane activity than average? That's what we don't know. Is that transition in the Atlantic Ocean taking place, or has the El Nino been masking this over the last few years? And that's what I mean when I said it's never happened in one of these heightened periods of 4 straight years of near to below average. So now that the masking aspect of the El Nino is out of the way, we'll get a pretty good sense this year. So, but we don't know exactly what phase that this MAO is in. That's one part of the uncertainty. The other uncertainty is, even though we're headed in a La Nina, the atmosphere tends to lag a little bit behind the actual ocean temperature. So even though we are headed into a La Nina, there could be some kind of like an El Nino hangover in the atmosphere that would prevent a whole lot of storms. So those two components make this season a very difficult one to predict.
Okay, very interesting. Another question from our attendees related to the accuracy of models. The question specifically asking about, is there a difference in the accuracy of North American versus European models? And there's a specific reference to Joaquin and its track, where it was predicted to move something like the way Sandy did by the North American models, and had a different track that was, I suppose, better predicted by the European models. Do you have any comments on that?
Yeah, that was a very interesting thing that we were looking at last year. Just to kind of backtrack a little bit, for Sandy, when Sandy developed, there was one model, the European model, that showed the storm come up, intensify as a post-tropical storm, and then make this sharp left-hand turn and make landfall somewhere along the mid-Atlantic states. And the European model had this 7 days ahead of time, where most of the other models from North America, the GFS in the US, and our global model here in Canada, had Sandy go off out to sea. As the days got closer to Sandy making landfall, our models here in North America started to kind of shift back to falling in line with what the European models were saying, and eventually most of the models all agreed on the same scenario, which was Sandy making landfall somewhere in New Jersey, which was exactly what ended up happening. With Joaquin, it was the opposite, where a lot of the North American models had Joaquin, once it finished making that track towards the southwest, come up and follow a track very similar to what was the eventual track that Sandy took. But one model, again the European model, except for 1 or 2 runs, had Joaquin staying offshore. And it took a couple of days, but the North American models ended up kind of falling in line with the European model. So Joaquin was was another case showing that the European model handled that particular storm really well. And a lot was made of Sandy when the European model handled Sandy 7 days ahead of time, while the others did not quite do so well. And then we saw another case here in Joaquin, where it was a kind of a different scenario, but same thing where the models differed, and then the North American group came in line with what the European model was saying. Now, those are two high-profile cases. There are a lot of other cases where both our global model and the American GFS did a much better job than the European model. You just don't hear of those cases quite as much for reasons I'm not sure why, but there have been a couple of winter storms, for example, one I think last year or the year before, where the European model had something like 90 centimeters of snow for New York City, and they basically shut down New York City, and they only got about 20 centimeters of snow, which the GFS and our Canadian model had pegged from the get-go, and the European model was off. But so much weight was put on the American model for that winter storm because of how well it had performed during Sandy. So there was an interesting dynamic there as to how much credibility the European model was, and it's one of the top models in the world, but it doesn't get every single storm right, whereas some you can say that for any kind of model, essentially.
Okay, great, thanks. Another sort of a topic you discussed in the presentation was the change in size and speed of storms as they move into Canada. The storm forward motion increases and the area they cover increases. Why is this?
Well, when these storms are in the tropics, they're kind of their own entity. There's nothing else around them that actually has much of an influence on them when they're in the pure tropical state. Once they start to make that curve, that move towards the north or the northwest or northeast or wherever they're going, they start to interact with the jet stream, and that essentially causes differences in upper level winds with the storm, and it makes the storm take on the structure of a winter storm or something that looks like a winter storm or a strong spring storm. Those types of storms, the what we call extratropical storms, are by their nature, they're larger than tropical systems. So once the structure of the storm changes, first of all, it gets influenced by the jet stream, so the steering winds are faster, so the storm increases in forward motion. The other aspect of it is because it takes on a different structure. It takes on the different structure of a storm that's inherently bigger than its own tropical when it's in its tropical phase. So, and that's something that we see in pretty much all the cases, is that the storms get bigger, they increase in forward motion, and the rain is pretty much the heaviest rain. Any kind of damaging rain is on the left-hand side of the track, while the strongest winds are on the right-hand side of the track. So those four things it helps us tremendously when we're trying to forecast these things, because we're expecting those four things to happen, and invariably they always do.
Okay, so another question related to that topic is related to damages. So you mentioned in the presentation that 81% of the storms that you had observed had higher winds on the right-hand side compared to the left. Has there been any association between that differential in wind speed and damages? So that's question one. And second question is, do you have a sense of the relative damages caused by water as opposed to wind in Atlantic Canada during these storms?
I'll answer the second part of the question. The answer to the second part is we don't have any hard numbers to back up one or the other. Most of the damage that we saw, if we look at, some of the more, relatively recent major storms that we had, if we look at the two storms where Canada has made an application to get removed from those lists of names, and that would be Hurricane Juan and Hurricane Igor that impacted Newfoundland. The damage in Newfoundland was primarily because of the heavy rainfall, so basically water related, whereas most of the damage that we saw, even though we did see some storm surge damage, most of the damage that we saw here in Nova Scotia and Prince Edward Island with Hurricane Juan was a result of wind damage. So it all depends on where the storm is tracking and what kind of other aspects of the storm are in play at that particular time. We saw Arthur 2 years ago that had a major impact in New Brunswick and here in Nova Scotia, and that was primarily wind, but it was wind on the left-hand side of the track. In New Brunswick, at least, that caused all the damage and tree damage and power outages and the damage that resulted because of the extended power outages and all that stuff. And I'm not sure I quite got the gist of the first part of the question.
Well, the first part of the question, I think, was aimed at if there's been any analysis of the amount of wind damages on one side of the track as opposed to the other, and if there was a significant difference.
Oh, okay. There hasn't been any specific study on that, but I would definitely say that there is a significant difference in damage reported on the right versus the left. For instance, Hurricane Juan, I mentioned most of the damage was wind related. If you can almost cut it with a knife. You can look at the right-hand side of the track versus the left-hand side. And the left-hand side, people are still wondering what all the fuss was about because they didn't get much of anything. So there is a very significant difference.
Okay, great. One last question. We're getting just a little past 11 here, so maybe we'll wrap it up after this. So great presentation. Can you speak to the impact of climate change on hurricane intensity and frequency, i.e. lower frequency but higher intensity?
Yeah, and that's something that that we've tried to take a look at, and especially there's been a lot more work done in the U.S. than we've really focused on here with that. But essentially, that's basically what we're looking at is that there's the result of climate change. Yes, there would be warmer water, which would typically give you more storms on average, but it also would have an impact on wind shear over the tropical oceans as well. And I'm not just talking about the Atlantic now, I'm talking about any ocean basin. So because of that, you would not necessarily see more storms, but you may see the storms that do form will be slightly more intense. And I've seen numbers about 3 to 5 or 6% more intense. So even though the water is actually warming up, first of all, in the Atlantic, if I just focus on the Atlantic for 1 second, this AMO would have a bigger impact than climate change on tropical cyclones in the Atlantic. But overall, globally, there may be fewer storms, but some of those storms may be slightly, and that's where this 3 to 5 or 6% comes in, might be slightly more more intense in terms of its wind speed.
Okay, great. Before we wrap it up, I'll invite you, Bob, say any last comments.
No, just a pleasure to do the briefing again this year, and hope to do it again next year.
Great. Well, I think we can definitely arrange for that. And thanks again for the excellent presentation. And just one last reminder to everyone online that we'll have our next Friday Forum on June 17th, where we'll have Dr. Eric Robinson from AIR talking about 3 catastrophe scenarios for Canada. check your inbox. I believe the invite was already sent. And with that, thanks again, everyone, for joining, and hopefully we'll see you again in June.